Hi, welcome back to the second part of this lesson on metamorphic temperatures and pressures. We've been looking at this graph showing us where the different geological processes actually occur in terms of their temperature and then pressure and depth. What I asked you to do was to try and match up the rock types with the conditions at which those rocks will form. Let's have a look at some answers to this. The first one is shale. Shale is a sedimentary rock. It forms at the surface as mud. It then gets buried to shallow depth, very low temperature, to form the sedimentary rock. If we then put that under some more pressure, and again relatively low temperatures, that shale or mudstone will turn to slate, where the pressure then starts to align the grains within it to create the cleavage, the foliation within it. If that slate then gets buried deeper in the crust, so it experiences higher temperatures and higher pressures, that will change then to schist. It recrystallizes. We start to see the clay minerals then turning into mica, for example. So schist is that higher temperature, higher grade metamorphic rock, but also made from a parent rock of mudstone. Now, if we keep on heating that schist until eventually it'll start to melt, what we'll actually see is the formation of a granite, which is an igneous rock, so must be to the right there of the partial melting curve. Now, the last two rocks I've put in here, it doesn't matter which order you put these in, because both of these rocks can form in any of these areas within the contact metamorphic zone. We've got marble, whose parent rock was limestone, and metaquartzite, whose parent rock was sandstone. These two rocks form at the same conditions, low pressures and relatively high temperatures. The difference between them is the parent rock that they come from. Okay, what I'd like you to do now, just to really firm up what we've been looking at with this graph, is to have a go at question 4 on page 7. See if you can fill in the answers to those questions from this information from the graph. We'll talk about the answers next time. So, as we see a little bit of art, a sunset over the Scottish Highlands. The picture's probably about the Highland cows, but I was just looking at the metamorphic rocks in the background, to be honest. We can see that the pressure and temperature conditions at which metamorphic rocks form is a crucial part of understanding the rock that we see. So we need to look for the whether it's got foliations or not, and the minerals that are in it to give us an indication of how much metamorphism there's been. But we always must bear in mind as well what the original parent rock was. We can't have, for example, a marble forming from a mudstone. It just doesn't happen. Okay, next time we need to start looking at the idea of a metamorphic aureole in a bit more detail. But that's for another lesson. I'll see you then.